Course 3, lesson, 105? Wow. We're calculating total average, I think is what they call it, or something to that effect. We used to call it overall average in the old books. It's the type of problem that makes sense when you learn it, but you don't realize you probably would have solved it a different way had you not learned you need to do it this way. Because the other way, as you'll learn, would get you slightly wrong answers. For example, Bianca bought 200 shares of XYZ stock at the average price of $54 per share. So what did she pay? Let's just break it down. What did she pay total if she bought 200 shares that cost $54 per share? That's an average, because no two shares are ever exactly the same, but they average them so that it's easy to calculate. So to find the total spent there, you do 200 times 54, right? Let's just find out what that is. 10,800. Now let's do it again with the next 100 shares. $60 per share gives us, that's easy, $6,000. Average price per share for all 300 shares. The way we find that is by adding this total price we just found, which comes to 16,800, and divide that by 300. Okay, that answer divided by 300, the average price per share in the end was 56. So obviously you can't just find the average of the two, because, you know, it's a weighted average. There's more 60 than there are 54. Or sorry, more 54 than there are 60. But also, when we were finding this, it might have been tempting to say, you know, well, I've got 300 shares total at an average of 54, okay, 57, okay, and then multiply that. You would have gotten close, but I don't think that's going to be exact, so don't think you can just average both and multiply them. Sorry. 300 times 57 is probably close. Yep. But because we took the total and just found the average before we multiplied, we got slightly wrong answers. So you have to actually find what is this, then actually find what is this, add them together to find the total spent, then average it, if that makes sense. We're doing something somewhat similar in the next one here. Let me just expand our screen. After 3 games of bowling, Gabe's average score was 88. Okay, we're finding an average. So 3 games, we don't know what they were, but they totaled an average of 88. So we'll just say 88, 88, 88. Even if they aren't all that way, that's what they average out to. That's the even stack if you put them all in a row. What score does Gabe need to average in his next 2 games to raise his average to 90? Remember how we find average? We take the sum of all the scores. We don't know the 4th and the 5th score yet. Let's call them both X because they're going to be averaged, so they can be the same. How many games total will it be? You divide by the total number of games, which is 5, right? 2 plus 3. The average needs to come to 90. All right? They kind of solve it this way without showing the algebra. I think it's easier to understand. You know, we put our 5 scores here. We divide by 5 equal 90. Now, what do I do with this? I can combine my like terms, right? So put your 2x's together. Now we multiply by 5 on each side so that that gets rid of this, giving me 450 on the right. And what's on the left? Add these like terms. 88 times 3. 264. So over here we have 2x plus 264. What do you do next in algebra? You subtract the 264. I know I can do this in my head. We got 6 and 8 and 1 equaling 2x. So what's each game got to average to get me to 90? 186 divided by 2 is 93 is the answer. At least 93 in the next 2 games to raise the overall average to 90. Last problem for today. Because of the heavy traffic, a 120-mile trip to San Diego took 3 hours. The traffic was lighter on the return trip, which took 2 hours. Here, let me get rid of. Same trip, right? Same distance. I'm just writing this out because I remember that distance is your speed times your time. So I just filled it in both trips. There, and then back. Went faster on the way back because the traffic was lighter. Find the average speed for each trip. Because obviously your speed probably fluctuates somewhat while you're driving, so we call it an average speed. But this average speed is going to be 40 because distance equals rate times time. This one would be 60. But what's interesting is you can't just go, okay, 40 plus 60 is 100 divided by 2. Average was overall 50. You can't do that. Like I was saying in the last problem, you try to skip ahead a little bit, that gets you a slightly wrong answer. Instead, we need to take 60, I think it's, I'm just going to make sure I don't do this wrong. You take the distances, okay. If distance equals rate times time, then let's just open up a new document here. Then we have to take both our distances, or both our rates, 40 and 60. Actually, no, that's what we're going to be finding, our average rate. If we want to find the rate, we're finding the distance divided by the time. Or if I want to show it the way I was just doing it, distance equals rate times time. So we're going to leave the rate as r. And then we have to add the times. 2 plus 3 was 5 hours. And the distance is 120 twice. So we divide by the total distance by the total time. And that comes to, hopefully the right answer, 48 instead of 50. So what was the point there? It was that you can't just find the speed for the first trip, the speed for the second trip, and average the speeds to find the overall average speed for the entire round trip. What you need to do is take the total distance equals r times the total time and basically use that to start again. So actually we didn't need the first two answers to find this. All right, so check out example 3 a little bit more if you need to think about this more or talk to a friend. But always remember that the distance of a trip can be found by multiplying speed times time, or rate times time. So if I'm going to find rate, I will end up dividing both sides by time. That gives me the rate. Okay? And if you've got multiple trips to deal with, okay, to find the rate, you're going to add up all the distances and divide it by add up all the times. That's what I'm saying. Do all 3 practice, please.